Hello, everybody. I'd like to welcome you to our presentation about the College of Computing and Informatics at Drexel University. As you can see on our second slide, my name is Greg Hislop. I'm a faculty member in the college. I teach both graduate and undergraduate courses. I teach our capstone design course, for instance, which is taken by all the students in the college. So at some point or other, I tend to see students from every one of our majors. The College of Computing and Informatics is a rather unusual unit, and not many universities in the country have a college like CCI, the College of Computing and Informatics. It's one of the most comprehensive academic units in the country if you're interested in anything related to computing or informatics topics. We are the focal point at Drexel for this kind of study. We have 5 undergraduate majors, and I'll spend a good bit of today's presentation talking about those majors. And we also, as is common across Drexel, we have a strong experiential learning approach, which gives us very close ties to industry. And I'll talk about that as well. We have a particular commitment to women in technology. And of course, we live in the heart of a Tier 1 research institution. Drexel is a very research-focused institution, in addition to being very technologically focused and very career-oriented. And of course, we're in the center of Philadelphia, which is a very large, very strong cultural center with a large, very diversified economy as well. Our next slide shows you a brief comment about our commitment to women in technology. If you weren't aware of it, we have a problem in our industry, the computing and informatics disciplines, in that we have a number of groups that are underrepresented, and we are trying to do what we can as a college to improve the diversity in our profession. And a big commitment we have in that area is to try and foster careers of women in technology. And we have a variety of efforts, scholarship efforts, support efforts, mentoring efforts that we hope will be particularly attractive to help women move into the profession. So CCI offers a wide range of academic opportunities for undergraduate students. As I mentioned earlier, we have a total of 5 degrees, and moving to our next slide, you can see what those 5 degrees are. We've got them here in the Drexel University colors, the blue and the gold color. We're not just doing that, though, out of school spirit. We're doing that because there are some fundamental differences that can help you to understand these degree programs based on those colors. So I want you to get this picture in mind as we go forward. In the next group of slides, we're going to talk about each one of these individual degree programs. And this will give you kind of the high-level view of how they relate to each other. So you notice the bar down at the bottom that starts in gold and then gradually transitions to the blue. That's one way to think about the left side of this diagram versus the right side. The degrees that are in the yellow color, the gold, the Drexel gold color, tend to be ones that emphasize more about computing theory and tend to be very much more software and programming oriented. So a different kind of technology. The degrees on the right side, the blue ones, are degrees that are much more interested in applying technology in order to meet people's needs. So they're much more focused on the clients and the organizations that are served by technology and how to use technology to meet those needs. So I'm going to talk about each one of those, but that gives you a sort of a high-level view of how the two might be separated into 2 different groupings. And in fact, if you looked at the organization of our college, you would find that the 2 degrees on the yellow side are in one of our departments, and the 2 degrees on the right side and the one at the bottom are in the other department. So we actually organized ourselves that way in terms of the organizational structure of the college. So what I'm going to do now is talk about each one of these, starting with computer science and going through each of the 5 degrees. We have a slide here about our computer science program. We actually have a couple slides about computer science, and I'll explain why in a moment. But computer science, as the name implies, computer science is a science. Science is about creation of knowledge. It's about theories. It's about advancing what we understand about a given area. Just as biology is about advancing what we understand, the knowledge about life, or chemistry, the knowledge about materials, computer science is where we get most of our theory that relates to computing. How do you compute? What computing is possible? How do you do computing more efficiently? And so on. And then there are a bunch of specialty areas that are lumped into that discipline as well. If you're interested in some of these specialty areas that are listed in the middle of the slide, computer science is probably the right major for you. Now, to understand the theory of computer science, one thing that's important to know is that in a degree like, or in a discipline like computing, theory really translates primarily into applied mathematics. So the students that are successful and attracted to computer science tend to be students who do quite well in math. Doesn't mean you want to be a mathematician. We do have students who are interested in math enough so that they'll do a major in computer science and a minor in mathematics. They really love math. That's a good fit to computer science. We have other students, though, who really don't want to do math as their thing when they go out in the professional world, but they can do it well. And they understand math and they can relate to math well. And they want to go and take that and use it to do computing. That's a good fit because the theory of computing mostly is drawn from applied mathematics. So if you do the computer science degree, there's a BS and a BA version, which gives you a little more flexibility if you want to do things like combine computer science and the humanities, for instance. But most of our students tend to do the BS degree, the Bachelor of Science. You get a foundation, which gives you computing theory. You get a lot of programming as a part of that, programming basics and beyond for more advanced programming topics, so that you understand how computing works, what's the science and theoretical basis for computing. And then you gradually start to build in these focus areas, which we call tracks. There's a whole bunch of them. We named some of the more popular ones here, but there's actually more beyond this. And a track is just a cluster of upper level courses. After you've taken your foundation courses, you take a cluster of 3 courses in one of these particular areas. So if you're interested in artificial intelligence, or you're interested in computer graphics, or you're interested in cybersecurity topics related to computer science, you would get those in your tracks, and you get to pick which ones you want to focus on. We also have a couple of concentrations, and I'll talk about these as we go along, particularly the game programming concentration, which are about the size of a couple of tracks. And so about around 6 course cluster, and then some additional courses that you may have to take as a part of your regular requirements. So that's computer science. It's the foundation area for computing. It's where the theory comes from. It's got close ties to mathematics, and you get to focus on some of these areas like artificial intelligence, AI, or graphics. If you want to design a new programming language, this would be the area for you. But we have one more slide on computer science that I want to mention. Turns out that a lot of students that are attracted to computer science are actually attracted because they're interested in gaming. So Drexel has a gaming program, and in fact there are 2 ways at Drexel that you can major in gaming. We have 2 different programs, and the 2 programs are connected to each other. Within computer science, you can take a computer science degree and then do a concentration in game programming. There's another college at Drexel, the Westfall College of Media Arts and Design, which has programs that are all about applied arts. So it's got programs in computer graphics, it's got programs in interior design and fashion design, other kinds of design informations, applied arts essentially, right? Media arts. It's got opportunities to learn about film, for instance. And in that college, there's a program in computer gaming. So what is the difference between these 2? If you come with CCI and you major in computer science, you end up with a general computer science degree and this concentration in gaming. What you're prepared to do is build the games. You're the person who understands the technology in depth. You're the person who can do the software development related to gaming. Those people in the CCI gaming program, pair with students who are in the Westfall College Media Arts program, right, which is a program in game design where they are interested in the artistic side. So the students from Westfall tend to be interested in the characters in the game, the look of the game, the aesthetics of the game, all the artistic parts of game development. And of course, if you're going to build a game in industry, what you have to do is put those 2 parts together. So we put our students together. So students in the CS program take some courses rather with the students in the gaming program in Westfall, who have the aesthetic sense and are interested in the artistic sides of the game, and they work together in teams to build games. In both of the colleges, as is common across many majors in Drexel, our seniors do what's called a senior capstone, which is a team-based course that runs all through senior year. And of course, the gaming students tend to build games for their senior project. And typically the way this will work is we'll have a group of CS students, computer science students in the gaming concentration, and they will pair with a group of students from Westfall who are seniors in their gaming program, and the 2 groups together will build a game over the course of their senior year for their senior capstone project. And of course, this kind of preparation is exactly what you would need to do if you go out in industry and work in a gaming studio. The gaming studio will have people who come with that software background, the computer science type background, and people who come with the artistic background as well. So it's a very hands-on, very typical of Drexel, very much career-oriented program that enables you to major in computer science and at the same time get the gaming experience that you need and if you want to work in a gaming studio. Now, for any parents who might be listening to this presentation, I would point out that our degree is not a degree in gaming, it's a degree in computer science. So students in our gaming program get all the basic foundational material in computer science, they take a lot of computer science courses, and then they mix that with all the courses they need in order to be working in the gaming industry. We often find that students do that, and by the time they graduate, along the way, they've gotten interested in artificial intelligence, or they've gotten interested in computer graphics, or they've gotten interested in human-computer interaction. And they end up deciding they really don't want to work in a gaming studio, and they use that computer science degree to be able to go work in other areas. So we've kept our program that way rather than having a game degree in CCI, because we feel it gives students a broader base for being able to do a lot of different kinds of careers in computer science. But if students go all the way through and they like the gaming parts of what they're doing, they can go ahead and work in a gaming studio. They're ready for that as well. So let's move on now from our computer science degree. Our next slide addresses software engineering. Software engineering is the degree that's most closely related to computer science. If you look at our overview slide from the beginning, you'll see that those were the two that were in yellow boxes. They're both closely tied to the theory of computing. But there's a separation here that we can make, and I'll do this by analogy. If you look at the area of chemistry, you have not only chemistry, but you also have something called chemical engineering. Why do we have both of those? Chemistry deals with science. It deals with advancing our knowledge about computing. So for instance, we have companies in the area like DuPont, where you have chemists who work in labs and try and create new kinds of fibers. DuPont has been involved with fibers like nylon and Dacron and rayon, many fibers that are used in our clothing. Right? But there's a difference between a scientist, a chemist in a lab, trying to figure out how to build a fiber using test tubes and beakers, and being able to actually manufacture that fiber at large scale. The manufacturing part is where an engineer comes in. So a chemical engineer knows all about how to create large quantities of something in an industrial context and be able to do that on a predictable budget at a predictable cost with a predictable level of quality. That's what engineering is all about. At the same time, a chemical engineer has to study chemistry and know a lot about the fundamentals of chemistry, but then know a lot of other things about how to do chemistry at industrial scale. The notion of software engineering is to do something similar with software. Software, it turns out, is really hard to build. Software is one of the most complex products that people have ever constructed. And it tends to be very hard to get it right, to have a very high quality software product. If you watch popular news even, you may see, oh, Apple has released a new version of their operating system. And then very often a few weeks later, if you follow the news closely enough, you'll see another little story that says, oh, Apple has a problem with that software they just released 2 weeks ago, and they have to send out an update to it. Why does that happen over and over again? It happens because software is hard. Apple, Google, Microsoft, pick your company, they are all trying to hire the smartest people they can find to build their software products. And they have very good software teams. But software is difficult. And software engineering has emerged over the decades as a way to try and address the problems we have with software and how hard it is to build. So software engineering, just like chemical engineering is based on chemistry, software engineering is based on computer science. So if you look at the first 2 years or so of courses that students in the software engineering degree take, you'll find they're taking most of their courses with the computer science students. But then as they go along through their program, they start to focus in more depth on certain topics that the computer science students don't spend as much time on. So they start to focus more on how do you understand the requirements for software, what it should do. How do you understand how to design software and how do you create a good design? How do you consider alternative designs and pick the best one? How do you do development so that you can stay on schedule as you're building a software product? How do you ensure the quality? How do you do testing and quality control for software? How do you manage software over time? as it changes, because software products change a great deal from the time they're first created until the time that they are last used. Our software products now often are found to last for decades, and they change a lot over the time that they're in service. That's one of the things that's actually different about software from many other kinds of engineering, is the level at which the product changes after its initial release. So software engineering is got all the basics of computer science, but then it layers on top of that all these other areas that I've just enumerated. How do you specify the software? How do you design the software? How do you allow the software to evolve over time after it's initially released? There's also a lot in this degree that focuses on how do you do software development in teams. So students in this degree, for instance, take a software project management course, which is all about how do you manage the work of an entire group rather than just an individual trying to write a program. So those are the separations between computer science and software engineering. They're both very much focused on software. Students in both of these programs tend to be people who like to program and like to write software, but they get different emphasis. They both get the same foundations in computing theory. Computer science students then go off and they focus on things like AI or gaming. Software engineering students go off and focus much more on these issues of how do you build software at an industrial scale and have reasonable level of quality. So let's move away from computer science and software engineering. Let's go to one of our other degrees. This is the one that's down at the bottom of the overview. It's our degree in computing security and technology. This is our operational cybersecurity degree program. So if you're interested in cybersecurity, you're interested in computer forensics, you're interested in how do you defend systems from attack, this is the degree program for you. It's very hands-on. It's very much about the technology of computing, what we refer to as the infrastructure of computing. Just as our transportation infrastructure involves trucking and roadways and rail lines, all the things we do in computing involve a great deal of infrastructure that day to day most of us don't think about. You know, we have these funny terms. We talk about, oh, I have data in the cloud. What does that really mean? It doesn't mean if you walk outside and you look up, you can see somebody's data floating around in the sky above you, right? It's a euphemism we use for this infrastructure. Everything we do with our cell phones, with our laptops, with any desktop computers you might have, with iPads that you use, so much of what you do is not contained in that device that's in your hand, your cell phone, for instance, but rather your cell phone is connected to a network, and that network is connected to servers, and those servers provide computing power, they provide storage for your data. Somebody has to be taking care of all of that. You know, we talk about my data's in the cloud. It really isn't. It's probably in this humongous building in somewhere like North Carolina that's just filled with row after row after row of servers and lots of storage and lots of network connections. Somebody has to take care of all that. Students in the CST degree, Computing and Security Technology, are the ones that know how to take care of that infrastructure. So their degree starts off with learning about the infrastructure, networks, servers, databases, web servers, and so on. And how do you deal with that infrastructure? How do you plan it? How do you install it? How do you manage it? How do you monitor it? How do you upgrade it? All those functions that need to be done day in and day out to keep that infrastructure humming, meeting people's needs, growing as our use of data and computers grow. So that's the computing technology side of the degree. At the same time, if you're in charge of infrastructure, doesn't matter what it is, network, servers, databases, it's under attack. Without question, it's under attack every day. To take an example, I have a little server in my office. It's on the internet, but it doesn't have any name, a URL that you would use to know how to reach it. You have to type in the number, the numeric address, what's called the IP address, in order to get to it. There's nothing on this server that anybody would care about. And yet if you watch the logs, it gets attacked every day. Not just once, typically 50 times a day, someone attacks that server. And so imagine if you're a corporation and you're trying to protect their data, or you're working for a company like Microsoft that has cloud services that they offer to anybody who wants to store things. They are getting attacked continuously. Right? So if you're going to be in this infrastructure area, you have to not only deal with computing technology, but you have to deal with security technology. And the students in our degree get that. So I always think of this degree as an upside down Y. Students start off with foundational material where they get the basics of computing technology, all the infrastructure topics, and they get the basics of computing security. And then they tend to specialize a little bit. That's the branching of the Y. They can either focus more on the security side or more on the technology side, but they continue to get some of both topics. So this is our operational security degree. This is our cybersecurity degree. If you want to work in cybersecurity, this is the degree that's good for you. We are a well-established program. We've been around for quite a while. We participate in a variety of programs that the federal government supports. The National Security Agency, for instance, has a designation where they designate centers of academic excellence in cybersecurity. Our program does carry that designation. There's also a cybersecurity, Cyber Corps for Service program, which provides scholarships for some of our upper level students in exchange for them going and working for government in security roles afterwards. We participate in that program as well. Many of our students, of course, go on and work in areas of industry. Pretty much every industry you can think of, any company you can think of, is trying to hire people who have this kind of background because they have these security problems and because they have infrastructure to maintain. Let's move on to one of our other degrees. We're now on the blue side of our diagram. This is where our degree in information systems and our degree in data science are. So these are degrees that are more focused on how do you apply technology to solve people's problems. Students in this area are taking a technical degree. If you look at their degree requirements, you'll find that their degree requirements are course after course after course, which are all about technology. But the emphasis on technology and what they want to learn and what they want to do with the technology differs significantly from the people who are in computer science or software engineering degree programs. We don't tend to get many students in these degrees who decide to be software developers, for instance. They tend instead to want to work with the software developers in order to create products that do something useful. So the students in this degree, information systems and also data science, are required to take a minor as a part of their degree. For both students, most often it's a minor in some area of business. And the reason for that is we want students to understand an area where they can apply technology. Most of our students end up applying technology in business. So they take a minor in business, they take a major in information systems, and they become people who can bridge two sides of the equation. They understand technology, they understand what software developers do, they understand how to work with software developers to specify solutions to problems, technical solutions to problems, and they also understand the people who are going to use those solutions. They understand the people working in different business areas that are going to be the clients for those solutions. So they become the interpreters or the bridge between the two sides of the equation. That's the heart of what the information systems students tend to be about, is applying technology to help solve people's problems. There are some specialty areas that they get into. Very often you'll find an IS student will get into what's called user experience or human-computer interaction. This is the area of making programs so that people can understand them and know what to do with them. You've probably had this experience where you download an app to your cell phone and then you open the app up and it's got buttons on it and you don't know what to do. Do I push this? Do I type something in? Or maybe you push a button and what you expected to happen isn't what happens. Something else happens. And it's like, whoa, that wasn't what I expected. User experience is about trying to avoid those problems. It's about trying to design applications so that when people open up the application or try to do something with the application, it's intuitively obvious to them how to do things and what the application is going to do. Right? So we have students, because they're interested in this issue of how do you make technology useful to people, we wind up with students that specialize in these user experience, or sometimes it's called human-computer interaction, those areas within the degree. Okay? But the whole idea is bridging these two worlds. Understanding the technology, they take lots of technology courses, and also understanding an application area, most often it's business. The other degree in this area, moving on to our next slide, is our BS in data science. This is a relatively new area. Many of you have probably heard of big data or data analytics. We have all these sources of data that have just mushroomed over the last decade in terms of data that's available to be processed. The problem is they don't tend to be very neatly structured, and they tend to be very difficult to work with, partly because they aren't so neatly structured, and also just because of the huge volume in which they occur. So this data is coming from two different sources. One source is that there's a lot more sensors in our world now. So people in science, people in engineering, even people in business, more and more are putting sensors out in the world and collecting data from those sensors. Those things produce volumes of data. So engineers are putting sensors all over bridges that measure temperature and humidity and movement. And they're generating these continuous streams of data. What do you do with that? How do you process it? It's cool that you can collect it, but it's a whole new class of problems to be able to deal with that. Similarly, we are all busily documenting ourselves. Things like Facebook, Instagram, Snapchat, all these social media applications that we use day in and day out are putting data that's available out to the public. And every company in the world wants to try and tap into that data to try and understand customer needs, who their customers are, how they can sell more things to their customers. It's mostly related to marketing. So those kind of problems, those are two big categories, require a different kind of computing. And our degree, BS in Data Science, is one of the degrees that has been created to help train people who can deal with these humongous sized data sets and this very unstructured data and try and help organizations do something useful with it. Now, as I said, as a part of this degree, like our IS degree, students are required to take a minor. If students are interested in processing Facebook data to help with marketing, they would probably take a minor in business and learn about business and data science and how to use data science techniques to solve business problems. We also have students that want to do a minor in something like public health or one of the natural sciences, biology, for instance. And what they will do then is they will take their data science knowledge and work with a team in that area, a team of biologists, for instance, to be able to help the biologists process these mountains of data that they've started to collect over the recent years. So that's data science. It's a very new area. It's the newest of our 5 degrees. But it's also a very hot area. When we talk to people in industry, they're all very interested in what our students know coming out of this degree and how they might be able to tap into that student population in order to solve problems that they have with big data. Now, at this point, you might be totally confused. You might say, hey, I know I want to do computing, but I really don't know which one of these degrees is for me. I'm still trying to figure it out. And in fact, if you go to many schools, you might find they only have one computing degree. Right? Drexel's a different kind of a place. We don't have one computing degree. We have an entire college devoted to computing and informatics, and we have our 5 degrees within that college. Why are we giving you this kind of a problem? Computing and informatics, if you're looking at what we do with computing, it is such a large area of what people do, such a large segment of our economy, that we can't prepare people for all these jobs unless we have multiple degrees in order to do this. This is similar in a way to the way engineering evolved decades ago, where you don't just have, I'm an engineer, but you have, I'm a chemical engineer, I'm a civil engineer, I'm a mechanical engineer, different specialty areas. Or you can look at the medical profession, where it's not just, I go to the medical guy or woman. You know, it's instead, I see a doctor, I deal with a nurse, I deal with a physical therapist, I deal with a physician's assistant. We have all these specialty areas because there's so much to do that we need people with different kinds of training in order to get the work done. The same thing is true in computing and informatics. Drexel is a very technologically oriented institution. We have created this college because we are trying to expand to address the various kind of needs and prepare students for the various kind of degrees, the various kind of careers, rather, that people have in the area of computing and informatics. And it's ever expanding. We just a few years ago added data science because that area has emerged in the last decade. So we have these 5 degrees. You're sitting in high school probably, or just out of high school, and you're trying to figure out, how do you relate to this? You know you want to do computing, but you're not sure what in computing you might want to do. We offer these 5 choices. Most of our students come in and they pick one of these choices and they go with it. It is possible to change majors. As with any change of major, it's always easier to change the sooner you figure out what you want. But in freshman year, for all of our students, we have courses that are designed to expose you to each of these 5 majors. But we have another option that we've added just in the last year or two as well, and that is you can come in and say, hey, I'd like to be in computing and informatics. I know that I want to be in this area. I really don't know what major I want. Then you can apply as CCI undeclared, and we will work with you during the freshman year to help you figure out which one of the 5 majors you want to try. So you come in, as CCI, you're admitted as CCI undeclared. We start working with you over the summer. You take the normal math placement exams. All our students take those. We give you an additional survey to start to talk about what kind of things interest you in computing. And then during the fall and into the winter quarter, so that's from September up toward the end of March, you'll work with our advising team in order to figure out what courses to sort of try a few of the areas. You can work with the advisors to talk about the majors. You can work with faculty. I'm involved with doing this among other faculty to talk to them about the different majors and what you think your interests are. And the whole goal would be through these additional sessions and through advising to figure out by the end of the winter quarter, so that's around the end of March of your freshman year, to figure out which one of the degrees you want to try, and then you switch from undeclared to one of the majors by the time you get to the end of your freshman year. So that's an option there as well if you really just think you need a little more time and you aren't comfortable with picking one and trying that. So those are our 5 degree programs. The next slide here, we're back to our comprehensive coverage of computing and informatics. We've got our 5 degrees that you saw at one of our first slides, and now we've got some areas to extend that out to kind of summarize some of what I've said. So on the left, we have our yellow Drexel Gold boxes. We've got computer science, that we highlight some of the specialty areas. Clearly, if you're interested in software development and programming, computer science is a good choice. This is the degree that most emphasizes computing theory. If you're interested in computing theory beyond the basics, you definitely want to be in computer science. This is where our game concentration is, if that's your interest. If you know that what you want to do is develop software products and you want to be as prepared for that as you can, you might want to take the foundations with the computer science students and then do the upper level courses in software engineering, which will give you much more about quality assurance, about software design, software architecture, how to work with teams, how to do project management with teams, and so on. But both of those degrees are very much focused on computing theory, software development, lots and lots of programming. That's why they're in the yellow block. If I go over to the other side on the blue squares, we have our degrees that are about applying technology to solve problems. Down in the lower right-hand side, information systems, it's about creating wonderful user experiences. It's about working as the translator between the technology side, the software engineers, for instance, and the business people, let's say, to figure out how to design, how to specify products. It's also very often about data and information management. They get into that as well. And then if you really want to focus on these very large scale data problems, we have our data science degree, where students deal with how to do social media analytics, how to do business analytics, how to interpret results, how to visualize data, how to do something called data mining, which is trying to find the nuggets of useful information in very large piles of data. Right? So both of those technical degrees, but focused on applying rather than creating new technology. And then our one down the bottom, we can't decide computing and security technology. This is a really technical hands-on degree, so we make it half yellow and half blue. It's about applying technology. It's a very hands-on degree in that sense. It's operational cybersecurity, but it's also about how do you build, manage, monitor, upgrade the infrastructure of technology. So if you're interested in cybersecurity, applying cybersecurity, this is a good degree for you. If you're interested in infrastructure, servers, networks, databases, taking care of those things, managing those things, this is the degree for you as well. So that's our set of degrees. So let's turn away from direct discussion of the 5 degree programs and talk a little bit about what it's like to be a student here and some of the other things that really impact being a student at CCI. Our next slide gives you a little overview of what do you do during your first year? What would you actually study? Everybody comes into Drexel taking exams before they arrive. The principal one for our students is an exam that helps to put you into the right math courses. And then you spend your first year, you'll take some mathematics. You take some introductory coursework in your own major area. So there's an introduction to information system, foundations of computer science, and so on that you would get. Everybody gets some introductory level programming, although that tends to differ a little bit for the yellow degrees. Software engineering and computer science take a more intensive programming course. The blue degrees, data science and information systems, take something that's more oriented toward things like web programming and something called scripting. You get a course that's a transition to college life course. We start to get you ready for co-op. I'm going to talk about co-op in a moment, but we don't just throw you in the deep end on co-op. You spend time during your freshman year getting ready for co-op. We do that right away. You also take all of our students in CCI, take what we refer to as a CCI first year design sequence. So this is a course that you take all 3 quarters in freshman year, fall, winter, and spring quarter. And this is where we do what I mentioned before, which is we explore the basics of each of the majors. You have some labs, for instance, to give you some feel for what's information systems about, what is data science about, and so on, for all the different majors, no matter what major you think you're gonna be in. We also have our students work on a team project. Almost all of these areas, software engineering is all about teamwork, but the other degrees as well, very often students wind up doing things in teams when they're out in their careers. So we spend time freshman year giving you a feel for what it's like to do a technical project in a team. Now, you may be sitting there as a high school student and think, oh no, I can't do that. I can't work on a team project when I'm a freshman. You can. One of the things that you'll note is that the way we have our curriculum set up is we don't assume you come in with any particular knowledge other than a general high school degree. If you're admitted to Drexel, we are a competitive admissions school. We know you've done well as a high school student. That's all that's necessary. In particular, don't worry about how much computing you have taken before you get to Drexel. The truth of the matter is that most high schools in the country do not have anything significant in the way of computing education. So if you're in a school where there's no computing courses available at all, that's okay. We expect that coming in. You may find out that you're sitting next to somebody in your first class and they've taken 5 computing courses in high school. Don't let that throw you. Don't let that intimidate you. Right? The faculty, as faculty, we know that our students come in with a broad range from no computing courses to lots of computing courses, and we build the curriculum to allow for that. So expect that when you come in, and you'll be able to deal with that. If you get accepted, you can do our program. If you meet the general criteria for Drexel. So you get those courses, you get that first year experience, the first year design sequence. You'll also take some general courses, you'll take some mathematics, you'll take some English. Depending on the major, you'll get some science in either the first or the second year. And that'll get you going down the road. Now let's talk a little more broadly about the degree programs. One of the key items, if you haven't really done a deep dive on Drexel yet, or you're still trying to understand about Drexel, one of the things you really want to understand is co-op, cooperative education at Drexel. On the next slide here, co-op education, my 17th slide, I have a little outline of how co-op works. Let me make a more general comment. I hope by this time, when you're looking at different colleges, you've gone around to different colleges, you've watched some presentations like this online. If you look at who has internships or co-op programs of some sort, if you go to a college and you say, do you have an internship program? Everybody will say, yes, we do. And they're right, they do. What you have to do is go down a level deeper than that and look at what role does that program play in the life of those students. At Drexel, co-op is at the heart of the DNA of the institution. Right? We are celebrating the 100th year of our co-op program. We've been at this for a long time. Everybody on campus, just about, very high percent, 90 some odd percent of all Drexel students do co-op. In the case of CCI, all of our students are required to do co-op as a part of their program. Everybody does co-op. So you can do co-op in 2 ways, and they're shown in these little diagrams off to the right. There's basically 2 patterns. There's a 5-year program where you do a regular academic year in your first year and your last year, freshman and senior. And in the middle 3 years, you spend 6 months in class and 6 months on co-op. So by the time you graduate, you have a 1.5 years of work experience. You can also, if you don't want to do that for some reason, you can also do a 4-year program where you take a regular 4-year academic program. In your 3rd year, you do 1 6-month co-op. So you graduate in 4 years with 1 6-month co-op. In actuality, if you look at our student population, if you look at our graduating senior class, what you would find is around 90% of all the students in CCI do the 5-year program. So our typical student, by the time they graduate, the most common pattern is they've been there for 5 years. They've got a 1.5 years work experience by the time they graduate. That puts them in a completely different situation in terms of how they look to an employer. It also means they have people that they know in 1 or more employers. Very often they have a job offer from an employer that has been a co-op employer that they can then have the option to go and work for after they graduate. It also changes what happens in the classroom. I teach very often, I'll teach software engineering courses. By the time I'm teaching juniors and seniors, they have a year to a year and a half's work experience. So if I talk about a software project, or I talk about a software team, or I talk about something that might happen in a large software product after it's 10 years old, there almost always are multiple students in the class that have stories that they can share about experiences they've had on co-op that relate to the topic that we're covering. So it changes what goes on in a classroom. It changes students' understanding of what they're learning and why they're learning it. It changes what students have in terms of what they can present to an employer when they go out on the job market after they graduate. And it is everybody in CCI. It's not a handful of people go and do internships. It's everybody going back and forth from co-op to class. A note for parents, if you look at this pattern, please recognize that whether you do the 3-year program or you do the 5-year program, you're on campus for 12 quarters. You only pay tuition for the quarters where you're on campus. So the 4-year program and the 5-year program, the total tuition bill is the same. A lot of times people don't catch that point and they think, oh, I don't want to do a 5-year program because it'll be another year's tuition. That's not the way the program works at all. Total tuition bill for 4 years or 5 years is the same. So moving to the next slide, I still want to be talking about co-op, but what we have here are the logos from a series of co-op employers that we regularly deal with. As I mentioned, co-op is Drexel-wide. A very high percentage of all Drexel students do co-op. So co-op is a major operation for the university. We have an office that deals with co-op and also career planning and placement called the Steinbright Center. You can look them up on the web if you're interested. They have a lot of interesting data about co-op there. But Drexel deals with on the order of 1,600 or 1,700 co-op employers year in and year out. And we have thousands of students coming and going from co-op. And on 6-month cycles, either fall, winter, or spring, summer. Students are either in class or on co-op. And we have students moving back and forth all the time. So we have about 30 people that do nothing but spend their time managing co-op relationships. In an area like Philadelphia, pretty much every large employer in the area is a Drexel co-op employer. The ones we show here are ones that we deal with in CCI cycle after cycle. Every 6 months, we have students coming back from or going to pretty much every one of these co-op locations. For students that are thinking about the notion of co-op, one thing is you'll do this as sophomores. Students are ready to do this. You should know that our employers understand we send students out typically sophomore with pre-junior, that's the extra year we have in the 5-year program, a junior year. Co-op employers understand that what a sophomore can do is different than what a junior can do on co-op, and they tailor the co-ops for that. At the same time, these co-op employers put a big effort into making sure that the co-op is an interesting technical experience. You're not going to be running the copier or making coffee for people. That's not what co-op is about. And the reason for that is employers do co-op because they're looking for people they want to hire. They're interested in developing students. They're interested in interesting students in what they do. And so they want to make sure that co-op is a good experience. We also have the enviable position in CCI in that every co-op cycle have more co-op positions open than we have students to put into co-op positions. So co-op employers do different things for students at different levels because they want to attract students to their co-ops. As I said, we have more students available to take, we have more co-op positions available than we have students to send on them. Oftentimes, the employers, when they talk to us, say, how do we get more co-op students? Because they have more positions that they would like to fill, because they have more jobs that they would like to hire for when the students graduate. One last thing I'll say about this, the world of co-op employers is much larger than you might think. You probably wouldn't be surprised to see Comcast, which is a technology company, our co-op employers, or Lockheed Martin, because they're a defense technology company. They do a lot of technology work. Let me mention Wawa here in particular. Wawa is a company that many of you are familiar with if you're in the Philadelphia area, and you think of them in terms of coffee and hoagies. They're also a very sophisticated IT company, and I've talked to their IT people. If you go into a typical Wawa store, you see the coffee rack. What they think about is the fact that they have 20 to 30 devices in that store where they're keeping track of what's going on and being able to manage the store operations, make sure that their supplies reach the store on time and so forth. They have a server in the back room that connects to their centralized data center. So there are a lot of opportunities on co-op that involve companies that you probably haven't heard of at this point in your education that will turn out to be fascinating places to work and really excellent co-op opportunities. You can go and work at a tech company if you want. We have lots of those, but there are many others that students get involved with that turn out to be really interesting as well. So let's move to the next slide. This is a kind of a summary slide in a way, and just want to point out to where does this all lead? One of the lovely things we have for CCI is our students are in very high demand in industry. And this pie chart tells the reason why. These are statistics, projections done by the federal government, the US Bureau of Labor Statistics. They try and project out jobs over about the next 10 years. This is a job projection for STEM jobs, science, technology, engineering, and mathematics. That includes computing, through 2028. If you look at those projections, you get a pie chart like this if you add them up. About 3/4 of all the new jobs that are projected between now and 2028 are related to computing. That means tons of opportunity. It's a great position to be in if you're a student coming in. By the time you graduate, there's still going to be very high demand. Our students graduating year after year are in very high demand, no matter which of these majors they choose, whether they pick any of our 5 majors. They're all in high demand because there's so much demand for people in these various areas of technology. So great news for you. Good reason for you to continue to consider the major that you're considering. Now, let's shift gears again. Life at Drexel is not all about co-op and going to employers and studying. Right? We are a regular university. We tend to have students that are very career-oriented. I do think that's a fair thing to say about Drexel. But we also have students who are all about playing in various ways as well. So your time here, you'll be involved not only in the academics and in co-op, but you have a full range of sports. We're a Division I athletic team, but we also have a whole bunch of club athletic teams, intramural athletic teams, and hundreds of clubs. For anything you can imagine, there probably is a club. If there's not, you can start a club. My office used to look over a courtyard outside our gym. There's a club of students that are I forget what they call the club, but their main activity is fighting, doing laser sword fighting. Think Star Trek. And around dusk, they would appear out there with these lit up swords, and they would do all these elaborate sword fighting using Star Trek type laser swords. So our next slide shows us pictures of 5 students that we have that are Dean's Ambassadors. We have a whole group of Dean's Ambassadors that are drawn from all of our majors. If you make it to campus for an event, you'll get to meet some of the Dean's Ambassadors. If that's difficult for you to do for one reason or another, you can get in touch with these students online. You can, there's a website address here that we list. Go there, you can see the profiles of different students. You can see what majors they're in. Pick one of them, send them an email, and they will chat with you. You have questions about what is it like to be a student here? What's it really like to study? What are the professors really like? What's it like in the labs? You know, what do you do on the weekends? Is everybody there? What kind of activities are you involved in? You name it. Whatever question you want to ask student to student, here's the way that you do it. So we strongly encourage you to get in touch with one of these students that's in a major you're interested in or some major you're just curious about. They're all happy to chat with you. So please do take advantage of that. It's a whole nother way, especially if you can't get to campus. If you can get here, you can talk to some of these students face to face. If you can't, then talk to them by email or arrange a chat, or they'll Skype with you or do some other kind of video chat if you want to do that as well. Okay, about time to wrap up here. I hope we haven't overwhelmed you with all this information. If you have questions, in addition to the student ambassadors, we have our admissions team on my slide here, 22. We can show you how different ways to connect with CCI. You can tune into our Facebook channel. You can go out to YouTube. We have videos out there. Right? You've got ways you can connect with us on whatever your preferred approach to social media is. You can contact Matt or Ines or Amanda, talk to them. You can talk to me. My email is at the beginning of this presentation. If you want to send me an email about something, I'd be happy to talk about the curriculum or about details of some of the courses that we have. If you're interested in that, shoot me an email as well. Probably quicker to get in touch with one of these guys, but don't hesitate to touch me as well if that will make sense for you. So I hope this has been helpful to you. CCI is an exciting place to be. We've just moved into a brand new building. just newly constructed. We have 2.5 floors and a tower with all kinds of space for our students to hang out, interact with each other, work together, little pod rooms that they can go into and do teamwork. Everybody's there mixing all day long in this exciting space. Our building we moved into partly because it's a building that's full of incubator and startup space. There are about 6 floors of little companies in there, many of them technology companies that are doing startups. So it's a way for our students to live in the sort of environment that many of them end up working with on co-op or after they graduate. And we're in University City. We had to move a couple blocks west of our old home in order to get this, this exciting new space. But we're right in the area that Drexel is expanding into. We've got a building behind us that's they're just breaking ground on. That's going to be a medical tower, and it's going to be the home about 2 years out, the home of our nursing school as well. They'll be right behind where our building is. So it's a really exciting time on campus. We hope that you'll find something that sounds interesting to you, that you think you can really click with in our degree programs, and that you'll decide to come and study with us at CCI. We would welcome you to campus. And if you're accepted at Drexel, you will be able to be successful. We know how to work with all the students who come into us as freshmen, turn them into these people that can do these co-ops and then graduate and go on to these amazing careers in some area of computing or information technology. Thanks very much for listening. I hope we'll see you at the College of Computing and Informatics.